So first thing we are going to do is radius of curvature. Let me explain what do we mean by radius of curvature. Given a small curve, say AB, suppose this is that curve, we can consider AB as an arc of a circle. The radius of that circle, suppose this is the radius of that circle. Radius of that circle is called the radius of curvature for that curve. The effect about this radius of curvature is illustrated in the right side figure. There is a small circle and there is a large circle. Both are touching at the point, say P. Smaller circle has the center O. Larger circle has the center O dash. I take a curve, say AB. If I consider AB, the curve AB, as an arc of the smaller circle, then means arc of smaller circle means radius of curvature is small, suppose small r. Then this is the angle formed, and that is the angle AOB. But if I consider AB curve as an arc of a larger circle means whose radius is more, that is suppose capital R, then this is the angle formed at the center, that is AO dash B. Clearly angle AOB is greater than angle AO dash B. This means that more is the radius of curvature, less is the angle subtended at the center, if arc length is kept same. If arc length is kept same. See, AB arc has suppose length L. So if radius of curvature is small r, that is we are considering it as the part or arc of the smaller circle of radius small r, then angle subtended at the center is angle AOB. And if we consider the same arc length, same curve of length L as the arc of a larger circle, that means a circle with more radius of curvature, then the angle subtended is AO dash B at the center. And from the figure, it is very clear that angle AOB at the center of the smaller circle, that is with the smaller radius of curvature, is more than the angle subtended at the center of larger circle. That means a circle with larger radius of curvature. If we measure angle in radians, as in the morning class we have seen, we have the relationship between the arc length, the radius, and the angle formed at the center, theta. So it means L by R is equal to theta. If L is kept constant, radius is increased. So if fraction has got numerator constant and denominator is increasing, what will happen? The fraction will decrease. Yes. The fraction will decrease. Okay. Yes. Is it clear? Anmol? Or any doubt? Daman? Gurjot? Gurman? Nobody is speaking. Man?
Yes.
Is it clear?
Yes.
Okay. So can I proceed to the next page? We will see the use of this. We have the application of this in turning angle of a railway track. Suppose there is a railway track. This is the railway track. I have shown with the black color. The railway track is laid straight up to this point, suppose A. But from A, turning of the track starts up to the point B. The track turns from the point A to point B, and after the point B, it goes again straight. So first, if there would have been no turning, the track would have been going in this direction. But because of the turning from A to B, now the track is going in this direction. So what is the angle of turning of the track? This is the angle theta. Or I can show here, this is the angle theta. Turning of the track's angle. Can we prove that this angle is also same as theta? The angle subtended at the center? Yes. Anybody who can see this, that we can prove it? See. This is angle 90 degree. See, repeating, there is a railway track shown here. the railway track is straight up to the point A. From the point A, the railway track starts turning. The turning continues till the point B, and after that, the track is straight again. So the angle of turning is how much? If the track would have gone straight in this direction, and if the track now has gone in this direction finally, how much angle it has turned through? If we produce this line back, and this is the angle theta, which is angle made between the initial direction of the track and the final direction of the track. That is, this is the turning angle of the railway track. We want to prove that the angle subtended here at the center O of the circle is also the same. We will prove it. See, this angle is 90 degree and this angle is 90 degree. Anyone who can tell the reason? Yes.
Yes.
Yes. Radius is perpendicular to the tangent. These tracks are tangent to the circle, and these are the radii. Here the radius is perpendicular to tangent. Here radius is also perpendicular to tangent. Is that clear? So now if this angle is theta, how much this angle is equal to? Can I write it as 180 degree minus theta? Because linear pair, the two angles sum should be 180 degree. Is that point clear? So if this angle is suppose x, the unknown angle, so this point is suppose C, in the quadrilateral, OACB, angle x plus 90 degree plus 180 degree minus theta plus 90 degree is equal to 360 degree. 90 plus 180 plus 90 is how much? It is 360 degree. So it cancels. So x is equal to theta. I hope this is clear. Yes.
Sir, yes.
Sir, yes.
Okay. So x is same as theta. So this means that if the radius of curvature be known to us, the radius of the track, the radius of the turning track be known to us, and we want to turn the track through a known angle, suppose theta, which is, let us take an example, 45 degree, and radius of curvature is suppose 175 meter. We want to find how much is the length of the curved track AB. Length of curved track AB we want to find. Suppose we want to turn the track through 45 degree angle, and radius of curvature is 175 meter. This is taken to be a large value because for the larger radius, the turning is easy for the train. Now length of the curved track AB we want to find, suppose L. L will be equal to R theta because this angle is also same as theta. Angle subtended at the center theta and this angle is same. So if this is 45 degree, this is also 45 degree. Radius is known, we can find the arc length of AB, that is length L. But when the angle theta is measured in radians, not in degrees. So now here is the use of the relation which we studied in the morning class. We know that 180 degree is equal to pi radian. So 1 degree will be equal to pi upon 180 radian. Therefore 45 degree is how much? Pi divided by 180 multiplied by 45 radian. Even if I don't write C, it stands for radian as I told in the morning class. So this is equal to pi by 4. This is how much? Pi by 4 radian. Now this is the value of the angle we can use here. So length of the curved track AB is given by radius, which we can take 175 meter, multiply by angle in radian, that is pi by 4. So putting the value of pi as 3.14, dividing by 4, so this much fraction we have to multiply by 175 and answer will be in the meter. So this is equal to 175 multiply by point, let us do the other way, 0.785 multiply by 175. So 5, 25, then 42, 39, then multiplication with 7, and finally the multiplication with 1, 785. So let me write the answer here. Here I am writing the total 5, this is 7, 9, 9, 18 and 5, 23. Then 5, 4, 9, 8, 17, 6 and 7, 13. Decimal after 3 place. So this is the answer 137.375 meter. Is that clear? Yes? Or
Sir,
anything?
yes.
So can I proceed to the next? So sharing the screen. we are going to find a method to find the distance of a star. S is a star and U and V are two stations of observation. At these stations U and V on Earth, which are separated through a distance d, we measure the angle of the star with the horizontal direction. That means suppose at the point U, we measure the angle to be x. From the right side, we measure the angle x. And at the second station, suppose the angle is measured equal to y. Then angle theta at the star can be calculated because x plus theta is equal to y. Anybody who can tell the reason? Yes, Navraj. Man. Jasmeet. Anmol. Nobody says. Yes. See, in triangle SUV, angle x plus theta, this is the sum of two interior angles, which is equal to exterior angle y. So this is exterior angle property. Yes, Anmol, in the chat you have given the correct answer. Therefore, angle theta can be found as the difference of these two angles. That is the angle subtended at observatory V and angle subtended at the observation station U. So angle theta can be found. Now, because the star is very far away, its distance from the two stations on Earth can be taken equal to the same. So if the distance of the star from the station U is capital D, it is same as from the station V. So this is an isosceles triangle, you can say. Or you can say if we draw an arc taking S as the center and D as the radius, that arc will pass through both the points U and V. And suppose arc length is direct UV distance is D. We have taken the distance between the two stations is D. This is known to us. This is a known quantity. Angle X and angle Y have been actually measured from these stations. So these are also known. So their difference theta is also known. But what is unknown? The distance of the star, capital D, we have to calculate. So what I was saying that taking S as the center, capital D as the radius, we draw an arc. It will pass through the both stations points U and V. Suppose the arc length, this is arc length, it is L. Can I say that L is very nearly equal to D? Yes. Can I say that L is equal to D. Yes, I will give you a practical example, our own words example. We live on a planet Earth, which is round, which is not straight, you know.
Sir, yes.
But suppose I go on the straight road, I travel on the straight road, and suppose I can see some point on this road 1 kilometer away. Up to say 1 kilometer distance, I can't observe that the road is curved. Though the road is curved actually, but why it looks straight to me or any one of you? Say for 1 kilometer, 1 kilometer is a very small distance as compared to the circumference of the earth, because earth is very large sphere. So a very small part of a circle can be taken as a straight line. Is it okay? And why earth is a very large sphere? Because its radius is how much? Its radius is 6,400 kilometers. And this is very small as compared to the distance of the star, which is millions of kilometers. So if you are drawing a circle taking S as the center and millions of kilometers as the radius, so for a small distance d on the earth, the arc and the straight distance will coincide actually. You won't be able to distinguish between the arc and the straight segment. I hope this point is clear. Yes. I think this point is clear. Yes.
Sir, repeat करियो.
Okay. Then I am taking that example again. We travel on earth. Suppose we are walking on the road. Suppose this is that straight road which we walk. If the straight road would have been very long, say 1,000 kilometers, it won't be straight because earth is not a plane surface. Earth is a spherical surface. So what would have happened if you think of a 1,000 kilometer, not meter, 1,000 kilometer long road, you would have seen it as an arc. But if you are traveling or you are watching only 1 kilometer, so 1 kilometer piece of the road will be very small. It will be very small. It will look straight, and this is what we practically see when we move on the road. We have the idea of how much 1 kilometer is. So in up to a distance of 1 kilometer or even 2 kilometer, if we are able to see, you find the road to be straight, not turning like this, can be upside down, it is going. Okay. Why? Because earth is a very small large sphere, because its radius is very large, 6,400 kilometer as compared to the distance we are traveling on the surface, say 1 kilometer. Okay. So for very small distances on a circle, you can say very small part of a circle, a very small part of a circle, a very small part of a circle is just straight. It can be thought of as straight. Okay. I hope, Man, is it clear?
Sir, yes.
And same thing is happening here, but more than that, the distance of the star is not just 1,000 or 6,000 kilometer away. It is millions of kilometer away. And if you are drawing a arc, taking the star as the center and radius as this distance, the arc length L will be simply the same as the straight distance, because you won't be able to distinguish between the arc and the straight distance. Here in the diagram, I am showing these two things separate because I want to make the things clear. But actually, arc won't be distinguished from the straight line segment. Is it clear, man? Anmol,
Yes.
Anmol,
Yes, sir.
Daman,
Yes, sir.
Gurjot,
Yes, sir.
Sukhman,
Yes, sir.
Bansirat,
Yes, sir.
Jasmeet,
Yes, sir.
okay, Jashan
Yes, sir.
and Jasmine.
Sir, yes. Yes, sir.
So I have reached to the end of this result. Matlab, the main point which I was to make clear is now over. Now what is to be done? In the morning class, we have found the relationship between the arc length, the radius, and the angle. Now arc length is same as the distance between the two stations U and V. Arc length is same as the straight distance. This point I have made clear. Angle theta we have known, y minus x. And this radius, which we have taken to be the distance of the star, capital D, this is unknown. Small d is known, the angles y and x are known, so their difference is known. We can calculate this very simply. So the distance of the star, capital D, is given by the distance between the station divided by the difference between the angles. But provided this difference, this angle is in radians. Sometimes in the future class, when I will be discussing very small angles, actually the angle formed at the star is very, very, very small. It is not even 1 degree. It is even smaller than that. So how do we convert the smaller angles to the radians? That is a practical thing which we can take in some other class. So when we will be converting the angle, this a fraction of a degree, a very small fraction of a degree into radians, and we will substitute its value here. The distance small d is known, then capital D, that is the distance of the star, can be calculated. Okay. So is it clear? Yes. Yes, now Anmol, any point, any doubt? Gurjot, Jashan, Ma, all are quiet. I don't think the last point has any trouble. Let me see in the chat box. Yes. I hope, is this clear to everyone? If you, any one of you say no, I
Yeah.
can repeat. Yes. Is it okay? And if it is okay, then I can close the class. Otherwise, I can repeat. Anybody who says repeat? No. So let us close the class here. Okay. I think I am stopping the sharing. I am